All right, so now let's go talk a little bit more about phenols. Again, what characterizes a phenol is the OH group bound to a benzene ring. And we'll see, especially when we start talking about physical properties, how they really differ from alcohols. Phenols were traditionally used as antiseptics, which are like topical antibiotics. So things that will kill the microorganisms on your skin. Our simplest phenol is just phenol. These guys are more complicated phenols. We're not going to really worry how to name them when they have multiple benzene rings attached. But it is interesting to note that these two are the main active ingredients in Lysol, right? So Lysol is, of course, famous for being able to kill 99.99% of all surface bacteria, including the coronavirus, which I guess is a virus, not a bacteria. But anyway, able to kill all those little microscopic bugs, right? And so the two main ingredients that are used are actually phenols, right? So this has a phenol functional group, this has a phenol functional group, and then they're decorated with a few other substituents. They were actually the primary antiseptic or antibiotic that was used for a really long time. The problem is that they are more antibiotics than something like ethanol, which basically means that a bacteria could actually grow to create a resistance to it. And so we don't like to overuse our antibiotics. I mean, that's a whole other situation, especially when you're talking about livestock and stuff, whether or not they're overused. But we don't like to put too much antibiotics out into the world because that just sort of encourages antibiotic resistance. You want to use them sparingly. So although they used to be sort of the main ingredient in something like a hand sanitizer, or, this is pre-COVID, so something used to clean an area before a surgery, that's now been changed out with just simple ethanol. Ethanol works a little bit different than one of these in terms of how it affects the cell. Ethanol sort of just like degrades the outside of a bacteria. It doesn't work its way in and do anything fancy like antibiotics do. Okay, so nomenclature. So first of all, again, the simplest, well, just take a step back. When we're talking about nomenclature of phenols, what you want to do is think about it just like pretty much exactly like benzene, but now the parent chain is the phenol. So our simplest phenol is just called phenol, right? Nothing special. When we decorate it with, say, another chlorine, this would be 3-chlorophenol, right? So notice how it keeps that name, that phenol name. And then the 3 is the position of the chlorine relative to the OH group. Similar over here, we have our phenol parent chain, so that's going to be the ending. And now we have an ethyl group, a 2-carbon group at position 4. So this would be 4-ethyl phenol. Likewise over here, this is now a methyl group, a 1-carbon group. So this would be 3-methyl phenol. And again, I just want to point out, you're sort of treating that phenol group as if it was the parent chain. Now, there's a fancier way to name these when you have 2 substituents on a benzene ring, and that is the ortho-meta-para designations. I didn't want to go too far into that because it seems like it's a little bit above like the pay grade of this course, but I do keep on seeing it over and over again, so I do want to sort of mention it real quick. Ortho-meta-para corresponds to how far away these 2 substituents are from one another. So we always sort of, here's our base substituent, the OH group that we're talking about, right? That's what makes a phenol a phenol. The ortho position is the next door neighbor. The meta position is one more removed, and then the para position is on the other side, okay? I think about this as OMP, and I kind of say it like OMG as a way to hammer it into my brain, but going in sort of from starting off close to that substituent, it's OMP. Those are these different positions, okay? They only ever work to describe a benzene ring that has two different things sticking off of it. So another name for 3-chlorophenol would be metachlorophenol, or M. This one would be on the opposite side, right? So that's the para position. So this would be para-ethylphenol. Again, this is in the the meta position. So M, I guess this has its own special name. Cresol. We're not gonna bother trying to memorize all those names of all the special ones. I'm gonna focus very much so on you guys knowing this, but I'm gonna mention these other names in case we do stumble upon it on an ACS or something, so you guys are a little prepared and not completely taken aback. Okay, so now let's figure out how to name this. First of all, what's our parent chain? Phenol, right? So right off the bat, I know this is something phenol. Okay, now you can sort of do this just like we were talking about the parent chain. We know that that OH group has to be at position 1. 1, 2, 3, 4, 5, 6. And then we could go the other way too, just to be sure. 1, 2, 3, 4, 5, 6. So which numbering scheme are we going to choose, red or purple? Again, the whole name of the game is using the lowest possible numbers. So in this case, the red is what's going to be our correct nomenclature scheme. So this would be 3-bromophenol. And instead, if we wanted to use that fancy designation, again, these are the O positions, the M positions, and the P positions. So this could also be called meta-bromophenol. Okay, so not too bad, especially if you've gotten from the aromatic compounds lectures down on how to name benzene. Naming phenols should be relatively a breeze.